Hey guys, we're back again, and we're going to start my favorite part of what we get to learn, and that's how to do math the right way. So we're going to talk about lesson 7-2 and 7-3, because we're going to lump together two operations together, and we're going to learn the true way in solving equations using addition or subtraction. And I'm going to change, not spell out the words. It'll be a much shorter title. And today's date is 2/25/19. So what kind of equations are we talking about? Well, we're talking about something that looks like this. X plus 7 or 3 equals 7. And x minus 7 equals 15. Now, I know you've probably seen something like this, or maybe even, again, something with a box, and your job was to figure out what was the mystery number that would go in the box so the left side would add up to equal the right side, or the left side you would subtract and it would equal the right side. Nope, no more of that baby stuff, my friends. We are going to use inverse operations, and so that's what our focus is in this chapter, is how to use inverse operations to get the variable alone in order to solve for the value of the variable. So these are operations that undo each other. Okay. And in this particular lesson, we're going to talk about the first two, that addition undoes subtraction, and that subtraction undoes addition. And then in 2 notes from now, we're going to do multiplication undoes division, and division undoes multiplication. Okay, so those are the pairs. Adding and subtracting is one pair, multiplying and dividing is a second pair. That helps us solve the equations. So what we're going to do is learn how to solve using inverse operations. Solve using inverse operations. Now, I don't want to hear this grumble. Actually, let's say solve. Let's solve equations using inverse operations. So remember, we talked about equations now are different than expressions because they now have an equal sign. And I don't want to hear grumbling about, I could do this in my head. Well, yeah, I would hope you would be able to do a lot of this in your head. Unfortunately, what we're doing is laying the foundation for how we solve problems for the rest of our mathematical careers. If you can't do this stuff now, algebra is going to be real hard, okay? So we're starting off easy. So we're going to just focus in on one. I know if you want to read through the lesson in the book, they talk about a visual, but to me, it's more of a pain than just learning the process. So let's do our 2 equations. So we had x plus 3 equals 7. Okay, so what we want to do is our goal, I'm going to put this in the center, goal is to get the variable alone. So in order to do that, we need to look at what's currently happening to the variable. So in this equation, what I notice is that I'm adding 3 to the variable. So what would be the inverse or opposite of adding 3? That would be subtracting 3. Now, the reason why I want to do this is look what happens when I add 3 and negative 3. When I add opposites, what do you get? Remember? Yep, that's right. We get 0. But wait, that's not all we're doing. If I'm going to do that to the left of the equal sign, in order to be fair, I have to do the same math to the right side of the equal sign. Now, this is called the subtraction, too long, property of equality. So equality equations. And what I'm doing is subtracting both sides by the same value. And that's going to give me x is all alone, equals, and 7 take away 3 is 4. Now I can check and see if 4 plus 3, does that actually equal 7? And the answer is yep. Oops, sorry. Checked before I wrote it. Yep. So what that tells me is that I've got it right. And by the way, that blue check doesn't look like a check, does it? There we go. So that's our check to make sure the math is right. So then we get x equals 4. So if the goal is to get the variable alone, something else we need to remember to do is treat both sides of the equation the same. So I treated the left by subtracting 3, the same as I did the right by subtracting by 3. And then again, we said 3 and negative 3 are opposites. Their sum equals 0. Okay, and that actually illustrates another property called the inverse property of addition. When I add opposites, I get 0. Okay, so I'm just going to write that down there. Inverse property of addition. Okay, so when I add opposites or inverses, I will get 0 every time. So let's look at the other one we had, which had x minus 7 equals 15. And now we ask ourselves, well, what am I going to do to get x alone? Well, the opposite of subtracting 7 would be adding 7. So I'm going to add 7 to both sides. Negative 7 and positive 7 are opposites, so their sum is going to equal 0. And then the identity property is what allows us to say, oh, x and 0 is going to give me x equals, and on the other side, 22. Now I can always do a check to make sure that my math is correct, and I'm going to put in 22 where I see x, and see if 22 take away 7 actually does equal 15. And the answer is, I'm pretty sure it does. Yep. I get 15 equals 15. So that just says, yep, x equals 22 is the correct answer. Okay, so we're going to do a couple of practices on our next page. Super simple, folks, but you got to show the work. Directions are going to say solve each equation, and it's not by guessing and checking. And then check your solution. Now, in addition to doing a lesson on how to solve adding and subtracting equations, we're also going to do one on using inverse operations in addition and subtraction word problems. So that'll be interesting. So first problem, we have 8 equals x plus 3. Now, I know this seems weird to have the x on the wrong side. We will turn that around. In fact, I could turn it around right now and take everything on the right and put it on the left, everything on the left and put it on the right. This is called the symmetric property of equality because it's over the equal sign. So we have permission to do that with this property. Okay, so I'm going to solve it, though, the way it is. And I've got x plus 3, so the inverse or opposite of adding 3 would be subtracting 3. So I'm going to do that to both sides. And I'm going to get 8 take away 3 is 5 equals, oh yeah, look over here. I add opposites, I'm going to get a 0, and x plus 0 is going to give me x. Now, protocol variable comes first because what you're doing is solving for x. So you're going to let the x show up first. Now, when it comes to these kinds of problems, we're going to make sure that we are always including the variable in the answer. when we do our word problems, you're going to see that we won't do that. So we have 5 plus 3, and 5 plus 3 does equal 8, so that's just verification. That has to be the answer. Okay, let's do another one. We've got, our old friend decimal. Hello. We have 3.5 plus y equals 12.75, or 3 and 5/10 plus y equals 12 and 75/100. All right, so the inverse of adding that 3.5 would be subtracting 3.5. So remember, we're going to line up decimal points. We're going to also annex a 0 so that both numbers are the same length. When we add opposites, we get 0. So that's going to leave me y equals, and then we're going to subtract over here. So 5 take away 0 is 5. 7 take away 5 is 2. There's the decimal point. And 12 take away 3 is 9. So I'm definitely going to check this one first. I was a little glib last time. So I have 3.5 plus 9.25. And the question is, does that equal 12.75? So I'm going to rearrange these vertically. It's easier to add that way. See, I get a 5. I can bring that decimal down. A 7. And I get it. Yep, I get 12.75 equals 12.75. Bing, bing. So we know that y equals 9 and 25/100 is correct. Okay, let's see what else I throw your way. Ooh, how about a little fraction? Little fraction action, huh? So I get x plus 3 equals 5/6. So the inverse of adding 1/3 would be subtracting 1/3. And when I add opposites, they equal 0. And I get on the left just x equals. Now, what do we need to do in order to add fractions, or subtract them for that matter, is we need a common denominator. So what's the smallest number both 3 and 6 can go into? And it turns out it's 6. So always test the little guy to see if he can go into the big guy. And if he does, the big guy is your least common denominator. So I didn't change the 6, which means I don't change the 5. But I am going to have to multiply 3 by 2 to become 6. So I'm going to multiply the top one by 2. Now this is not really negative 1. It is subtracting by 1. So the operation is subtraction. Okay. So when I subtract 5, 6, and 2, 6, I get 3, 6. Sorry, my numbers are getting all smushy. But we have a little bit of an issue here, don't we? Yep. What we have is like terms, or common factor, sorry. Thinking back to last chapter, huh? And I get x equals 1/2. So I'm going to go check that. Forgot to put my little check over here. So we have 1/2 plus 1/3, and we want to know, does that equal 5/6? So again, I need to come up with a common denominator of 2 and 3, which would be 6. So I would multiply 2 times 3 and the numerator by 3, multiply the denominator on the second fraction by 2 and its numerator by 2. And 3/6 plus 2/6 equals 3/6. Sorry. Come on, mouth, catch up. 3/6 plus 2/6 is 5/6. And there we go. So, yep, x equals 1/2. Okay, so what we're going to do is switch gears, and now we're going to do 3 problems that are subtraction. So I get x minus 2 equals 3. And by the way, I can already hear you say, do we have to do the check? And I'm going to tell you this. No, nobody has to check anything, but do you really want me, the person that checks your work? Because if I'm checking your work and you get it wrong, you're losing points. Just think it would be safe insurance. Go ahead and check yourselves. So we have x take away 2. So opposite of taking away would be adding. So we're going to add 2 to both sides. So remember, it's always the number that's on the same side of the variable that we're doing the math with, okay? Now, let's see what we end up with. Well, we've got opposites again. They add up to give me 0. And I get x equals 5. So let's do our check in a different color. Let's do this weird green. So we want to check and see, is 5 take away 2, does that actually equal 3? 5 take away 2 equals 3. 3 does equal 3, so I know that x equals 5 is the correct answer. Hey, interesting, look at that. 1 and 4 have the same answer. All right, let's try number 3, 5. And here comes decimal. He's back again. X take away 1 and 5/10 equals 76 hundredths. Okay, so the inverse or opposite of subtracting 1.5 from x is to add 1.5. But if I do it to the x, I got to do it to both sides. So the thing we have to remember is to line up decimal points, annex zeros if we need to make the numbers the same length. So I have opposites here, negative 1/5 and positive 1/5. They're going to add up to equal 0. And I get x equals, and over here I'm going to add, and I get, put that decimal point in. We've got a 6, 12, carry the 1, and we get 2. So I'm going to go ahead and check and see if 2.26 is actually accurate. And if I subtract 1.5 from it, will I get 0.76? That's the question. So again, I'm going to line up decimal points, annex a 0, do my subtraction over here. I get a 6, bring down a decimal point. I'm going to have to rename. 12 take away 5 is 7, so yep. Oops, sorry. I get 0.76 is equal to 0.76. So that verifies, yep, x equals 2 and 26 hundredths. All right, last one. Number 6. Let's see if I can cram them in there. Guess who's here? We've got fraction. Yep, we've got 3/4 equals x minus 1/3. So again, I'm going to solve it the way it is. And I'm going to turn my answer around so that the variable comes first. I could do it at the beginning if I wanted to, but no. So I find x, and I notice next to it is a subtracting 1/3. So the inverse would be adding 1/3 to both sides. So, yep, I've got opposites again, and I get a 0, so this is going to give me equals x. Now, the problem with our two fractions, again, is we have to have common denominators. So the common denominator between 3 and 4 is just going to be their product, 12. So let's see, I had to multiply 4 by 3 to get to 12. 3 times 3 is 9. 3 times 4 is going to give me 12. 1 times 4 is 4. So when I subtract 9/12 and 4/12, I get 5/12. So I'm going to rearrange that and make it x equals 5/12. Okay, so I'm going to check it, but I'm going to check it off to the side since I seem to have crammed myself out of room here. And let's see if 3/4 is actually going to equal 5/12 minus 1/3. So the only thing that's going to need to change is that 1/3. I need him to have the same denominator, 12, and luckily 3 goes into that, so that is going to be the common denominator. So I had to multiply 3 times 4, so I multiply 1 by 4. Let's see. Did I do something wrong? I think I might have. Huh. That's not making sense. Oh, did you see what I did, guys? Man, that took me a while to catch. Yikes. Do you see what I did? Look over here. Look in red. It said to add 3. Look what I did. I subtracted it. What a dodo. And here I was thinking we were going to get done so fast today. Add. We're going to add. Oy, Rosner. So we get 13/12 equals x. So rearranging that, we get x equals 13/12. Now let's go check it since it didn't work out. And see what happened when I did my check and it's like that didn't work out. I had to stop and think about what I did wrong. So I'm going to go back. I've got 3/4. Does that equal 13/12 minus 1/3? So the same thing we had talked about. We are going to have to find a common denominator. 3 goes into 12, so 12 is going to be it. So I multiplied 3 times 4, and I have to multiply 1 times 4. And I get 3/4 equals 9/12. You're saying, well, those aren't the same. But guess what? I can actually simplify 9/12 by dividing it by 3, which gives me 3/4. So these are the same. So that verifies that x equals 13/12. There you have it, folks. Watch out for your boo-boos. Do your check so it can find the mistake before you say done. All right, we'll talk to you later. Bye.